Welcome to All This Math. This is Professor Parker, and tonight we're going to be going over an equation and how to solve this equation. All right, and this problem was specifically requested by one of my tutoring students, and I'm going to show how to step by step approach this type of equation and how to solve this type of equation. Now, there's a lot of things going on in this equation. First of all, it looks very long, right? You have a lot of things going on. You have a lot of terms. You have parentheses. You have variables in more than one place, right? You have a fraction. So I'm going to provide a step-by-step process of how to simplify this whole equation, right? And the methods required to do that, right? Because this type of equation can look intimidating, right? But I don't want you to be intimidated by it. As long as you watch this video, pay careful attention to this video, and take good notes, all right? And the benefit of it being on video is that you can pause it at any moment. You can rewind and all that, whatever you need to do. All right, so if I was doing this problem and I was solving for y, even though I have y here, and y here, what that means is what number makes this statement true. So we're looking for a number that I can multiply by 1/3, because 1/3 y means 1/3 times y, right? Plus, and then add 5 times the quantity of 4 minus 2 times that same number. That would be equal to, so what number would I end up when I do that? Would end up with? That would be equal to 4 times the same number y plus 1. That's what we're looking for. So there's a step-by-step process, okay? The first thing, honestly, that I would do in this problem is I would get rid of the parentheses. See, when we're doing mathematical problems, we want to know what to do, and then we need to know how to do it. So what and how? What and how? Just like when you're cooking dinner. You want to know what you want to make, and then you need to know how to make it. And then you go through those steps of how to make it, and when you're all done, you have your dinner. So I need to know what to do, and then I need to know how to do it. So the first thing I want to do is get rid of these parentheses. Now, the way I do it is by using something that we call the distributive property. Now, the distributive property means that I multiply the number outside of the parentheses by every and anything inside the parentheses. So I basically give or distribute this 5 to everything inside. So I give it to the 4 and also give it to the negative 2y. Now, if I'm doing this problem step by step, I'm not changing anything else in the whole equation. I'm only changing what's right here. So in my next step, I'm going to rewrite 1/3 y, and then I'm going to write the product of 5 and 4. Now, 5 times 4 is 20. So that becomes plus 20. And then 5 times negative 2y, because a minus sign and a negative sign are the same exact thing. Write that down in your notes. A minus sign and a negative sign are the same exact thing. So 5 times negative 2y is negative 10y. Now see how this 5 times the quantity, and we call this a quantity. We don't say 5 times parentheses 4 minus 2y. We call whatever's inside the parentheses, we call it a quantity, right? An amount. This becomes 20 minus 10y. Then on the right side, I'm not changing anything on the right side, not yet. I will, but not yet. All right. Now, keep an account of what has changed from one step to the next. This used to be 5 times the quantity, 4 minus 2y. Now we have 20 minus 10y. All right. Now, the way I approach these problems is, and everybody may not do it the same way, but what I think is the easiest and most efficient is to get rid of fractions. I don't like to have fractions in my equation, so I like to get rid of them. Now, a way to get rid of fractions is to multiply the entire equation by what's called the least common denominator, or the LCD. You may remember dealing with LCDs when you had to add or subtract fractions years ago. You only can add or subtract fractions when you have the same denominator, or what's called a common denominator. That's the CD part. And you want to pick the smallest, so that's the L part, the LCD, least or lowest common denominator. Now, so how do I find the lowest common denominator? I look at each term. I got 1, 2, 3, 4, 5 terms in this whole equation. I think about it like this. I say, okay, this is the only term that actually has a fraction in it. This is what I want to get rid of. So I need to imagine, let's say these were fractions. Let's say I treated this like a fraction and made it look like a fraction. the way you make any whole number or any integer look like a fraction is you write a 1 underneath of it. You give it a denominator of 1, because 20 is the same thing as 20 over 1. Negative 10y is the same thing as negative 10y over 1. 4y is the same thing as 4y over 1. 1 is the same thing as 1 over 1. So now what I'm doing is I'm basically comparing all these denominators. I got 3, 1, 1, 1, and 1. And then I ask myself, what's the LCD of 3, 1, 1, 1, and 1? So the smallest number that they can all divide into is 3, right? That would be the least common multiple or least common denominator. So I write off to the side on my paper, I say, okay, LCD is 3, right? And then I draw brackets, my next step, because we're doing this one step at a time. I draw brackets around the whole equation, right? And then I write a 3 outside. Now that means I'm going to multiply, just like how I multiplied 5 by everything inside these parentheses, I'm going to multiply 3 by everything inside of these brackets, one term at a time. So I do 3 times 1/3 y. 3 times 1/3 y. Think about this to yourself. What is 3 times 1/3? What is that? 3 times 1/3, that's 3/3. That's a whole. 3 times 1/3 is a whole. That's 1. And that's what you want to happen, because remember what we were trying to do. Always keep in mind what your purpose was. Like, what was the whole purpose of doing this step? To get rid of this fraction. So if I do 3 times 1/3, that gets rid of the fraction. I don't want the fraction, so I'm trying to get rid of it. So I accomplished my goal. So that leaves me with just plain y, right? But I can't just multiply the 3 by the fraction that I'm trying to get rid of. In order to keep the equation balanced, I have to multiply that LCD by everything inside the equation. Every single term. So then I got to do 3 times positive 20, which is plus 60. Then I got to do 3 times negative 10y, which is negative 30y. Then I write my equal sign. Then I got to do 3 times 4y, which is 12y. Then I got to do 3 times 1, which is positive 1. So now the fractions are gone. So now my parentheses are gone and my fractions are gone. So now I just got integers and variables. So the next thing I want to do is I want to try to get all my y's on one side of the equation and all my constants on the other side of the equation. And it doesn't matter whatever the equation is, if you have x's, y's, a's, b's, c's, d's, whatever the variable is, you want to isolate the variables on one side. I typically like to put my variables on the left side. You don't have to do that. You might want your variables on the right side. But what I do, the way I roll, I put all my variables on the left side, and then I put my constants on the right. That's called transposing. So put that in your notes. My next step is going to be to transpose. Now, a lot of math textbooks and a lot of math teachers and a lot of math professors are not like me. They don't teach students to transpose. But I don't know why they don't, but transposing makes sense. And I think you should learn how to transpose and become comfortable with that, right? So what does transpose mean? That means that I'm going to take all the y variables and make sure they're on the left. I'm going to move them over. And then anything that's a constant, like this 60 got to go. This 60 is going to move over to the other side of the equal sign and go over here. So it's going to look like this. I'm going to take this 12y, right? And I'm going to move it over here to the left side. And then I'm going to take this 60. And I'm going to move it over here to the right side. But one thing you got to keep in mind, whenever you switch the side that the term is on, whether it's a constant or a variable, you have to change its sign. If it was positive, it becomes negative. Make sure you write that in your notes. If it was positive, it becomes negative. If it was negative, it becomes positive. The sign must change. The term must become its exact opposite or its additive inverse. Make sure you put that in your notes. Switch the side, change the sign. That's what transpose means. Switch the side, change the sign. All right? That's what transpose means. So now when I write it over, look what's going to happen. I'm going to have y minus 12y minus 30y is equal to negative 60 plus 1. Now look what happened here. This 60 used to be on the left side. Now where's the 60? It's on the right side. And now it's negative. Now it doesn't matter if I write this negative 60 first and the 1 second, or do I have to write the 1 first and the negative 60 second? That does not matter. Once your terms are on the correct side, it doesn't matter what comes first, second, or third. Just like over here, I could have wrote the negative 12y first and then put plus y and minus 30y. I could have wrote negative 30y first and then put plus y minus 12y. Once the terms are on their correct side, it doesn't matter what's first, second, or third. It don't matter as long as they're on the correct side of the equal sign. The equal sign is the boundary. All right, so everything over here belongs over here. Now, the purpose of transposing is so that we can do something called combine like terms. You can only combine like terms if your like terms are all on the same side of the equation. Right here, I got 1, 2, 3. I got 3 y terms. I can combine them, right? It's like having money in 3 different places. I can take all that money, count it all up, and I add it all up, and I can see how much money I have altogether, right? Over here, I have a negative 60 and a 1. Those are like terms because those are constants. Those are integers. I can combine those. So what I'm going to do first is over here on the left side, I'm going to combine these. I got 1 minus 12. That gives me negative 11. Then I got negative 11 minus 30. That gives me negative 41. So negative 41y. And then on the right side, I got negative 60 plus 1, which gives me negative 59. All right? See how this problem started out? Real long and complex and involved a lot of different terms. Now look what we boiled it down to. That's all that's left, right? We're not finished yet, though, because when we solve an equation, we isolate the variable by itself, and we know what the variable is equal to, right? We haven't solved it yet because this y still has a coefficient that is not 1. This coefficient is negative 41. So we don't know what y is equal to. We know what negative 41 times y is equal to, but we don't know what y by itself is equal to. So the way now that you get y by itself is by looking at this negative 41, because you want to get rid of this negative 41. So the thing is, you need to ask yourself, what is that negative 41 doing? What operation is that negative 41 involved in? It's involved in multiplication with the y. And whenever you want to get rid of something when we're solving an equation, you need to apply the opposite operation. So you have to then ask yourself, what is the opposite of multiplying? What's the opposite of multiplying? Starts with a D. The opposite of multiplying is dividing. So that means you will divide by the same exact number, not positive 41, negative 41, the same exact number. You divide by negative 41 on the left. And also, whatever you do in an equation on one side of the equation, you have to also do on the other side of the equation. So then you divide that by negative 41. Boom, boom, they cancel out. Now, this is an ugly fraction. There's no way around it. It's just ugly. Like, you can't reduce this. Negative 59 over negative 41. But what you can do is get rid of the negative signs, because a negative divided by a negative yields you a positive. So now we got 59 over 41. These are both prime numbers. I know 41 is prime. I'm pretty sure 59 is prime. I'm not saying 59 is prime, right?
Yes.
Yeah, I know 57 is composite. 58 is composite because that's an even number. 60 is composite. That's another even number. Yeah, 59 is prime. So this is my answer. I can leave this as my answer, 59 over 41. Now, if you want to, you can convert this to a mixed numeral. You don't have to, though, because in algebra, we deal with improper fractions. We don't really convert the mixed numerals when we get to this level and when you're doing these type of problems, right? But I can convert the a mixed numeral if you want to. 41 divides into 59 one time. And then you ask yourself, what's the difference between 41 and 59? Because 1 times 41 is 41, so how many is left over? Or what's your remainder, right? 59 minus 41 is 18, right? And then you keep the denominator, which was 41. All right? Now, this is the final answer. I like this answer right here, though. I don't really deal with the mixed numerals, though. But if you like to, do your thing. But that's the final answer. One thing I do highly recommend is for you at home or wherever you are is to check your work, right? Now, I'm not gonna carry out the whole check process. But what I will do is I'll set it up for you, right? And then at home or wherever you are, I highly recommend you get into the habit of always checking your work, because when you check your work, you empower yourself, because then you don't got to wait for a teacher. You don't got to wait for a tutor. You don't got to wait for nobody else to validate whether you know what you're doing, whether your answer is correct. And you might have the answer wrong, and that's fine too, but then you can go back and figure out where your mistake was because you tried to check your work. So if I was going to check this, and I don't have space on the board right now, and I don't want to do the check right now, but I would go back to the original equation, right? Original equation, and wherever I see a y, I'm going to replace it with 59 over 41, right? So I would do 1/3 times 59 over 41 plus 5 times 4 minus 2 times 59 over 41 equals 4 times 59 over 41 plus 1. Now, what I mean by checking my work is that when I calculate the left side of this equation, when I use the order of operations, when I do my multiplication, then my subtraction, then my multiply by 5, when I multiply 1/3 times 59 over 41, when I add these two numbers together, that sum should equal the sum of this product and this number over here. And if it does, then that means that this answer is in fact correct. And I just verified that it was correct. All right. So I set that up for you wherever you, like I said, wherever you are at home or in a quiet place, check your work. All right. Thank you for tuning in. This has been All This Math. This will be on the YouTube channel. Check it out. If you have any questions, any further questions, any math problems that are troubling you and bugging you, you can send in pictures of requested math problems that you would like to see done on this board. You can send them into the All This Math Instagram page at All This Math, ALLTHISMATH. And this has been Professor Parker with another problem on the board. Peace.